Morning. I'm Richard Symons from Schneider Electric. I'm part of our rack systems line of business. So very much we're looking at the racks and enclosures, which obviously with OCP and the changes there, we're heavily involved there. But also we look upstream of that. So a lot of the customer feedback we have is around how do we actually deploy this? And of course that plays into the checklists you see from the colo side, but also any other customer who's looking to adopt this kind of technology. It's, from the feedback we're hearing, it's not a given that you just roll in an OCP rack into your existing infrastructure and away you go. It's a bit more complex than that. So what we wanted to do was talk about pod-based designs, pod being the next increment up from the rack, how you can use pod designs to support both OCP technologies, traditional technologies. We're seeing a lot of hybrid environments. It's not just rip it all out and start again with OCP. So how do we make it easier for customers to deploy OCP into an existing environment? As we mentioned, it's not just OCP, but as we are here, and OCP is a big community-led organization, so certainly the sharing we get and the feedback we get from customers in the OCP community is a lot more than some other hyperscale platforms where usually you hear about it when it's a problem. They've bought this POC pod for a different technology and it's not quite going into the data center. So hyperscale platforms and OCP were always considered kind of the thing just for the cloud providers, and we've heard over the years with OCP that there's an appetite and we're seeing it happen. These platforms are going outside of the hyperscale providers. We're seeing enterprises adopt it. Telco is obviously very strong in here. So it's no longer just this cloud thing that we can all, it's quite easy for them to build a large data center for a new technology platform. How do the rest of the people who are trying to adopt this fit it in and make it work for them? So very much we wanted to share it with the community, obviously get some feedback on this as well. What are you seeing in terms of whether you are a user of it, whether you are a solution provider integrating all of this equipment and deploying it for your customers? What are the challenges customers are seeing when it comes to adopting this new stuff? And Schneider's very much focused on the most efficient use of energy and sustainability. So for us, getting behind an organization like OCP is, it's trying to drive efficiency, it's trying to drive a better way of deploying these new platforms. So for us, we're very interested in working here. We speak to a lot of customers who are trying to deploy this stuff. So why is it a challenge? Well, let's go back to the basics of it. The traditional way of deploying IT, it's rows and rows of empty racks, and then people would be rack and stacking IT equipment on site. It still happens, but very much with OCP style technologies, with the solution providers we have in the community, that's changing. It's no longer these empty racks full of IT or the rack and stack taking place on site. So it's changing. Customers aren't necessarily used to this new way of doing things. And again, it's not just OCP. All of these new technologies we see with hyperconverged, converged, other hyperscale platforms, the chunk of IT is becoming the rack. It's not the IT device any longer. We heard that from Intel as well. They're talking about the rack scale element. And we're very much seeing it. So I guess just as a quick show of hands, are you all seeing that as well? The increment of IT is becoming the rack. It's not the U space anymore. Is anyone still seeing? Yeah. Yeah, we're seeing it outside of OCP as well with traditional designs, but it's these kind of communities, the solution providers really drive that rack scale implementation and deployment. So if the IT device or the increment of IT is moving from U spaces to racks, what happens in the white space itself? So what we're seeing is the old white space building block was the rack. Now it's becoming the pod, and again, Intel mentioned that with the whole pod scale notion. So with everything shifting, again, I keep going back to how customers, what they're used to. They're used to doing the server by server, rack by rack. When this shifts, what are the implications for them? How do they deploy it better? And moving on from that, it's a case of the innovation that's taking place. Let's just talk OCP here. Just in a short space of time, we've seen V1 come out, we've seen V2 come out. There's different implications of deploying those. You've got 12 volt DC, 48 volt DC, Project Olympus. All of these new technologies are coming on board at a rapid pace. It's probably a more, innovation is coming thick and fast versus what we've seen in the last kind of 10 years before that. So how do customers deal with that? It's not a case that someone might deploy V2 and then there's not going to be innovation for a long time. It's going to keep evolving, keep changing. So certainly all of these new innovations coming along are causing customers challenges when it comes to deploying. But also, and I touched on this earlier, it's not a case of all in on day one. Most customers we're speaking to are trying to do a proof of concept. They have an existing data center, so how do you fit a proof of concept for OCP v2, for example, into an existing data center? And also, when they do adopt it, we don't see them going all in. It's a phased approach. There's certain applications and workloads that have to run on the older style technology, or they run a little bit in parallel till they're fully comfortable with it. So it's dealing with this whole scenario of here's something new, it's different just from a shape and size of the rack, but also the power implications, could be cooling implications in there as well. And bottom line is customers are telling us it's not so easy just to put that into our existing data center and run it, and we're not ready to build a new data center specifically for this technology. So that's just a bit of background from what we're hearing from customers. Does anyone hear that as well? I mean, when your customers, or if you are a customer deploying this, are you hearing that it's just easy to roll this stuff in, or there are certain challenges? Yeah, a few nods. Yeah, okay. So, Aaron will now run through a bit around more specifics of what customers are hearing, and then he's going to talk about an approach we feel. We've used it with certain customers, got a lot of feedback from actually implementing this when they're transitioning from older technologies to newer technologies. He's going to run through a bit about that. And then again, we love your feedback on this because this is an evolving thing. We're not going to fix it first time. So we need the feedback from the community to say specific challenges you see from customers, or if you are a customer, and then we can work on trying to fix that as well. So I'll hand over to Aaron now.
Great, thanks, Richard. I'm Aaron Cotter. I'm a Director of Data Center Solutions for Schneider Electric. And at Schneider over the years, we've had an opportunity to work with many different types of customers, deploying all kinds of different data centers, very large, very small. And now, as customers are starting to deal with some of these new technologies that Richard was talking about, we're hearing some consistent challenges coming up that they're having to deal with to move toward this new technology. So one is, how can they keep up with it? How can they keep up with the pace? They want to take advantage of some of the efficiencies and cost savings, but it's not always clear how to actually implement that into their data centers. An example of that is OCP. So some customers might want to wholesale change over. They might want to do a few racks and try it out, or over time move toward OCP as a transition. This kind of goes to this idea of a flexible backbone. So customers are wanting to kind of future-proof, and they might not know exactly what the IT load is going to be in that space, but they want to keep some flexibility to be able to adapt and not get stuck kind of going down one path. So how can they maintain some of that flexibility? Another is around just the speed and scale. So we all know, we've heard about a lot about that this week, of just the continuing pace of size and needing to be able to respond very quickly based on customer demand. And then cost is always a concern. So what's a clean, efficient, cost-effective way to roll out that data center space? So as we thought about these challenges from customers, there's 3 big areas that we kind of emerged as maybe opportunities for improvement or better ways to deploy this IT. So one is generally around this idea of flexibility. So if you look at the way air containment's done a lot of times at this point is mounting directly to the racks. And that's going to limit the flexibility for different size or shape or height racks that would go into a particular row. A lot of times it will require cutting or drilling on site. So you might walk into a state-of-the-art data center and it has freezer flaps or plastic panels that are cut to do air containment that doesn't really fit the rest of this state-of-the-art deployment. Also around the power and cooling architectures, you might need to put all that power or cooling in ahead of time. It limits the modularity and the ability to adjust to different needs. And then all of that is going to make it harder to make adds or changes to your deployment as needed. Another general area is around just deployment being harder than it needs to be. And I'd say the kind of the big idea here is a lot of construction type of work versus assembly type of work. So examples of a ceiling grid, which you might need to put everything in ahead of time. It's hard to make changes to that later on. Raised floors we see, if you are putting a lot under that, it's going to create obstructions. It's hard to manage later on. And then just construction type of work in an IT environment is never necessarily a good thing creates dust and risk for your IT equipment. The third area is around just the traditional deployment not really being ideal for these integrated racks, as Richard was touching on, and getting away from the rack and stack on site and the fully integrated racks coming in. You don't necessarily want to be doing work on those racks, attaching things when you have that IT equipment. It might be tens or hundreds of thousands of dollars of IT equipment, and you don't want to be doing construction type of work and putting that equipment at risk. So as we thought about all of these different areas, a new architecture really kind of emerged, and Richard was touching on it, kind of moving toward this pod-based system to support the IT deployment. And this has a number of advantages in our mind over the traditional approach. So one is, because you can put this up and install all of the infrastructure independent of the IT racks, that's going to shorten that overall deployment cycle. So in parallel with IT being done, you can put all the infrastructure into place. You can easily mount all of the cable, fiber, ducting, whatever you need to on the pod structure and get away from some of that construction type of work. The racks can just easily roll in and out of place because you're not actually attaching the containment to the rack. So if for installation or if you need to do some maintenance or a change to a rack, you can just simply roll it out of place. And then it's going to, because we're decoupling the infrastructure from the IT deployment, it's going to make that overall deployment cycle easier and more predictable. So looking at some best practices with a pod-based system. So one is this freestanding frame. So because it's freestanding, as I mentioned, that does not have the attachment to the racks, and the racks can go in and out of place very easily. Another is flexibility to adjust in terms of the length of a row, the height of the racks in the row, and to have some ability to be able to keep that containment if you have different height racks or different width racks within a certain row. Another is to be able to expand to multi-pod deployment. So you have the single pod, but for larger deployments, you might need to expand that up to 3, 4, 5 frames to support more racks. And then to have some flexibility in terms of the cooling architecture. So to be hot aisle, cold aisle, to be able to have in-row or perimeter cooling, to be able to adapt to being on a raised floor or slab is another aspect of flexibility with these pods. Another best practice, I would say, is to be able to adapt to different types of power distribution. So depending on the density of a certain pod or the country you're in, you might have a different optimal power distribution. So to be able to adapt to that, to have a panel board that's mounted on the pod, to be able to hang a busway along the length of that pod, to do in-row power distribution, depending on what's really the optimal for that deployment. And then again, to be able to support all that copper, fiber, cabling right on that pod structure just makes all of that distribution a lot easier. So we have a couple white papers that we've done that are available on our website or in our booth. One is just on the general specifying of a pod, and that's actually something Rob had presented on last year. We have another one that's white paper 263, that's an analysis of more of a traditional type of deployment versus a pod-based deployment. And we have some analysis of some cost savings and some time savings on that deployment. So in the cost area, we have things like a simplified raised floor, getting rid of the ceiling grid, having those panel boards mounted right on the frame. Is going to help drive out some costs. So we had, I think, fairly conservatively, a 16% cost savings moving to this pod type of frame. And this is on a 2 megawatt data center. And you can see all the details of that. We'd love feedback on any of that analysis. Similarly, as part of that white paper, we have the savings around the deployment time. So kind of moving from that construction type of work, getting rid of the ceiling grid. And again, I think this is pretty conservative. You could look at doing things in parallel that could even drive out more of this time. So just summing that up, we have this changing environment, a lot of new technology coming, and a lot of demands for customers for more flexibility, speed, and driving out costs in that deployment. And we really think this pod-based system is a good approach to solving a lot of these challenges. And some of those benefits, really, it's around flexibility, speed, and cost are the big areas that we think can really get the benefit of these pod-based approach. So we have the couple white papers I mentioned, 260, 263, in our booth or on our website. We also have a reference design of a 5.2 megawatt pod-based data center and a trade-off tool, pod sizing calculator that you can put in some parameters and helps you figure out the right size and power for a certain pod architecture. And that's what we have. We, as Schneider, we want to get some feedback on our participation in the OCP community. We have a little survey in the back. If you could, I think you get an Amazon gift card drawing if you participate in the survey. So we'd love your feedback on any of that, and I'll open it up for questions. I don't know where we're at on time.
We're good.
Yep. Any questions on any of that?
I have a question. What is the power density that you're typically delivering to racks in a lot of the data centers you're building today?
I would say, in that like 6 to 10 kilowatts, I would say on average, but really we see a wide variety down to 2 or 3 kilowatts up, to much higher densities. So
can you break that down as a percentage? Like how much is like above 10 kilowatts or below 4 kilowatts, roughly? I hear a lot. One of the things that concerns me, I'm a thermal mechanical engineer, and I'm seeing a lot of these systems being discussed, and they're like, oh yeah, we want to throw 1,000 watts per U. And I'm thinking, well, if you guys are building 5 kilowatt racks, you're going to put 5 of these systems in the rack? And so that's where I think there's a disconnect between the system builders and what's actually makes sense from a deployment, electrical grid, and switching and that kind of sensitivities.
Right.
I'd say the vast majority is around that 10 kilowatt. But again, depending on the application, you have HPC, you can shoot all the way up. But yeah, I'd say that's more than 50% is around that number.
Okay.
Yeah, and there's obviously a lot of challenges that come from that higher density that, you need to be able to, cooling and everything else you need to be able to deal with. So.
Do you guys have some white papers that break down the costs of the different energies? Is there like a sweet spot in terms of deployment for total cost of ownership or total install cost?
By density.
By density, yeah.
I don't think we do, but that would be a...
There was one study a few years ago that I remember we did that looked at the cost, what's the sweet spot in facility cost for density, and it was 8 to 10 kW was what we had kind of come out with, and it had to do with a lot of how many rack PDUs you had to deploy to get, wasted capacity in racks, and then if you do too much, then there's a little bit more expense that you have to kind of remove the heat. So it was somewhere 8 to 12. Okay, cool.
Yeah.
We have an agreement from here.
So with these pod designs, and when you're deploying them out there, have you had any feedback or, I guess, backlash from building code and the inspectors for putting the roofs, building a building inside of a building?
Depending on the state, yes. So in the US, depends.
What have y'all done to mitigate that?
So in certain scenarios, we aren't allowed to put the roof on full stop for code reasons. So I think of one particular customer they were trying to do cold aisle containment, but no roof was allowed on top of it for fire suppression reasons. So there, we just didn't put the roof on. We had a duct, so it created the bathtub effect. I mean, honestly, when you look at it, ignoring the fire suppression bit, which we can't do, but if you ignore that, it wasn't optimal. However, given the codes, the restrictions we had to work within, it still kept the cold air where it was needing to be. The IT equipment's consuming it. So yeah, it's a case of we have to adapt to local codes, regulations, and the US with all of the states can vary. When we go globally as well, it becomes, we have similar challenges there. So wherever we go in the world, wherever we install these things, we have similar challenges, and sometimes it's certain distance from sprinkler heads, not allowed the roof at all. So yeah, we have to make those compromises to get it in with the code, because they can just stop it dead.
I'd just say we do have a number of different roof options available for our system. So we have a shrink panel roof or a dropout roof. We have where you can drop the sprinkler head into the pod. So a number of different options to try to deal with some of those different regulations.
So going back to your initial statement on this trend towards shipping racks full of equipment, pre-tested, pre-deployed, right? So we do a lot of that. One of the problems we have, and we've done large surveys of racks that are available in the market, and one of the things is you can't ship them full of equipment because they can't pass shipping, shock and vibe, and these types of things. So two-part question. One, OCP racks, right? Is there any standardization or any specifications out there around what the actual shipping specs are? And then the second part of that is, right, if you're going to ship it deployed with equipment, what things do you deploy connected? Are there testing on connector wear and all this kind of stuff that I think needs to be addressed before you start shipping racks full of equipment, right? So.
Yeah, so I think I forget the exact number, it might be 3,500 pounds for V2, might be a bit more. But that's the shipping weight load of those racks. So if there's a V2 approved rack out there, it should meet those standards. So that's in terms of just shipping it full of equipment. The other implications, they should go through all of the testing. Now, typically the testing is not done with real connectors and real IT equipment, right, it's weight load. So
do you plug in power when you're shipping it? Do you plug in networking? Right, all these connector wear issues and things are a real issue when you start shipping things full, right? So
yeah,
just be curious. Have you seen customers deploy full shipped racks? Have you had any feedback or anything you could tell us about? So.
Yeah, we usually see it when it turns up on site, and hopefully it's not broken. But yeah. No, it's a good point, because certainly one of the reasons, there's a few reasons why people will want to ship them fully integrated, but speed, Aaron showed it, we didn't go into great detail, but the timelines of paralleling that IT rack and stack while the build is going on certainly saves some time, but if everything's disconnected, you still have to be on site and connect it all. So I think it's a very good point that should probably in the rack and power group be brought up to say, well, I mean, no one wants to destroy all the kit when they're doing the testing, but there has to be some consideration around which connectors would break when they're undergoing ISTA testing, for example, things like that. So I'd say probably it's not quite there. Yeah. But we can take that up with them because we work with them on the rack spec as well. So.
So the open bridge rack, which is V2, we do order it from time to time, fully populated, 42 servers and 3 topper rack switches, completely cabled up, labeled to go. We roll it into place, plug it in, because the PDUs are already there, plug those PDUs in, 4 fibers to the uplink and turn it on, walk away. So we haven't had any problems with that. Usually the problems is guys taking it from the loading dock in and breaking off a pedestal or something. Mm-hmm. It's the normal right. Stuff that everybody has, but none of the ITs have any problems. Yeah, fidelity, Michael, sorry.
And that's really how it should be. That's how you get the full benefit of speeding up deployments, things like that. So yeah, good to hear that's working.
Just ask a question about the delivery pathway that you need to get these pods into, say, it's a co-location facility. That's, it's got a door that's 1.8 meters wide.
Good point, yeah.
How do you get that in?
We didn't necessarily go into the detail, and so obviously we have a design for this. It's not a concept, but generally speaking, to allow for considerations like that, the pod framework should be flat packable. So it's, the biggest piece is probably a door so big, and then it's all assembled on site. Now again, going back to that speed of deployment part of it, it needs to be quick and easy to actually assemble. We don't want it to be a construction project because then it's unique every time. So using very simple and fast assembly methods to construct the pod, and the one we're showing, it slots into place. We have one on our stand. You can come and kind of see it. Took some inspiration from warehouse shelving. So, it's designed to support a lot of weight, goes together very quickly with, you don't have to have a skilled labor set to actually construct that kind of thing. So it is a good point because, if that came in as a full pod like that, which it could be prefabricated if someone had a data center that was designed for it, but you're talking hours of savings, not days of savings with the assembly process.
Is it a toolless design? So
it's not 100% toolless. That's the utopia.
That's the version 2, maybe.
Yeah, hopefully, maybe version 6. No, it's a good point. No, it isn't. Again, if it was just supporting containment, you could absolutely do that. But when you start putting power on there, especially if you're supporting busway A and B feeds, getting to toolless is probably a little bit hairy. So it's a goal because that certainly speeds things up.
Yep.
Done?
All right, thank you very much.
Thank you.